Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so the first thing you should do is to make sure that the limit of this thing equals zero, because in order for a series to converge, the limit of this thing must equal zero. In this case, as n gets bigger and bigger, looking at the numerator, it will be that will dominate. Looking at the denominator, it will be this that will dominate as n gets bigger and bigger. So what you have is this, and you can tell that the limit of this thing equals zero. We've done this many times. So the limit of this thing equals zero. So we can't tell anything. If it's anything other than zero, then we can be 100% sure that it's going to diverge. But it equals zero, so we've got to do more work. Well, in order to do this, we should use a limit comparison test. So using the limit comparison test, as n gets bigger and bigger and bigger, the numerator will act as this. The denominator will act as this, because these are the dominant terms. Okay, so now we can tidy this up. It will be this, take away this, that will then give you this, and then we'll tidy this up. This will then become this, and then one, and then 4 over 7 is a constant, so you can actually take it out. So now if you look at this, this here is this here will converge. We've seen this many times. P series, where the P is bigger than 1. So we know for sure that this will diverge. This will converge. If this will converge, then when you times this constant, it will also converge, meaning that this thing here will also converge. Meaning that this thing here will also converge. Okay, so you are using the limits comparison test. Normally, we would compare. If you look at the limits comparison test, you would you want to know something about this series, and you would compare it with something that you know about. Well, in our case, we know something about this series here. So with the limits comparison test, this is what we're trying to investigate. We know nothing about this, but then we know something about this. So this is our Bn here. This is our An. So this is our An here. So we know nothing about this, but we know something about our Bn. Our Bn actually converge. Okay, so with the limits comparison test, it is this that we need to compare this with this. So that's our normal routine. But I want to show you in this video, I want to show you, rather than using this thing here, which we've always used in the past, you could alternatively compare this with this messy thing. But this messy thing actually turns out to be easier to compute later on. The point I'm trying to make here is that in the past we would always compare it with this, but my point here is that you can compare it with this, because we know that this thing is going to converge, because this thing converge, therefore this thing converge. If this thing converge, therefore this thing converge. The point here is that you can compare it with you can compare it with anything you want, but make sure you know something about this series, or you know this is going to converge. So in the past we would compare it with this series, but for the case of this video, let's just compare it with this. So we are going to use this and compare it with this. Okay, so limit comparison test. We always need to compute this value here, An divided by Bn. So we need to do An divided by Bn. So we need to get An divided by Bn. Dividing by Bn is the same as multiplying by the reciprocal of Bn. That will then give us this. So now you can see that, what is the limit of this as n heads towards infinity? Well, you can get this times this, this times this, this times this, but don't bother with this. Just look at the because as n heads as n tends to infinity, it will be this multiplying with this that will dominate. We can forget about this. So don't bother doing this, this, this. Just look at just look at the dominant terms. So this times this will then give you this. This times this will then give you this. Forget about these, because as n gets bigger and bigger, you can pretty much ignore these. So the limit will be will be 1. Now going back to here, so we've just computed this value and it equals 1. So we just computed this value here. We've just computed this value here and it equals 1. Well, 1 is bigger than 0. So this is our scenario here. So we don't care about R1 here is not 0, so we can forget about this. The number we just computed, the number we just computed is not infinity, so we can forget about this. So we should be looking at this scenario here, because the value we just computed, this value here is 1. Well, 1 is bigger than 0. Now we know nothing about this AM here, but we do know that this is going to converge. Therefore, remember, they both converge or they both diverge. But we know this is going to converge. We know BN converge. We know something about this. We know this is going to converge. Therefore, this must act in the same way as this BN. It must also converge. So overall, our series here will converge. Okay.